This next lesson is part 2, you might say, of our section 4-4 in our textbook. The section titled Proving Triangles Congruent. And in this one, like I said, I'm going to get you a little bit closer to where we're going to be ready to do proofs. So on problems like these, they're going to give you a picture, maybe something like this. And there's going to be some information that they give you to begin with as well. So in this picture, for example, they might say that AC is congruent to DC. Not only a good band, but those are congruent. And BC is congruent to EC. So let's say they just gave you that two things, those two bits of information. Okay, and what I want you to be able to do is I want you to be able to mark your drawing, and then I want you to be able to complete the following statement. Because they'll have a statement that says then that triangle ACB is congruent to blank and by blank. All right, so if I mark the stuff that I've given here, AC matches DC, those two sides match. BC matches EC, those two sides match. Now remember our shortcuts that we learned in our previous lesson. There was SSS, SAS, and ASA. Those were the three shortcuts we learned that can help us prove triangles congruent. So when I look at my picture here, I've only got two parts congruent. There must be a third pair of parts if I'm going to be able to prove them congruent. And remember, we also learned in our previous lesson there were two things that you got to watch out for. That's if triangles share a side, and watch out for vertical angles. When I look at this picture, I can see that this angle and this angle are vertical angles, so they would have to match. And that gives me just enough to prove the triangle is congruent now. As you can see, it's two pairs of sides on each triangle. If I were to cover that up, two sides, and that angle is the one in between. This side and that side meet at that angle. So SAS would be our shortcut, our method that we're going to use to prove the triangle is congruent. And going back to this, all we have to do is just fill that in. You really should be careful to make sure the order of the letters is the same, though. So if this one's called ACB, and if you see it's a reflection where you flip it over, then this is called DCE. Okay, so there's one problem like that. I'm going to show you a few of these, and then I'll cut you loose and have you do the homework on these. So let's try another one. This time, let's try one maybe that looks like this. Okay, and let's say that that is A, B, C, and D. And on our information that we're going to be given this time, let's say that we were given that, let's say that angle, no, let's do this. Let's say that side AD is congruent to side AB. And suppose that you were told that the segment AC bisects angle DAB. They want to know then if you can fill in this statement and mark the drawing. Don't forget to mark the drawing. Okay, on your homework, you'll be asked to make marks on your drawing as well. But they want you to be able to fill this in and say that triangle ABC is congruent to what other triangle and by what method. All right, so if I mark what they told me, AD is congruent to AB. There's a pair of sides. They also told me AC bisects angle DAB. Okay, when you hear that word bisects, remember in our 10 Commandments of Proofs, the word bisect should lead you to thinking that there are going to be two congruent parts, two smaller but equal parts. And it's always what follows the word bisects is what's being cut in half. So it's not two smaller sides, even though a side did the cutting. It's two smaller angles. They're saying this overall angle DAB just got split in half. So if I cut the overall angle DAB into two equal halves, two smaller but equal halves, it'd be those two right there at the top. It'd be both of the angle A's, one being called DAC, the other BAC. Now I've used up all my given information. I still need one more pair of parts to prove triangles congruent because all of our shortcuts require 3. So on a problem like this, there must be something else congruent. And what do you know? They share a side right here down the middle, AC. So I mark it congruent. And now I can see, once again, like on our last problem, we've got two sides and the angle in between. See that? Two sides and the angle in between. So I could say by SAS again that triangle ADC is congruent to triangle ABC. If you try to put those in the same order, see it's a flip again, a reflection. Let's see here. Let me try at least one more of these, just to make sure you're catching on to these. Let's see. How about okay, how about this one? And let's say that this is A, B, C, and D. We're going to give you up here that BD is perpendicular to AC and BD bisects angle ADC. They want you to show that triangle ABD is congruent to another triangle here yet, and by what method. All right, so if we look at what we're told so far, perpendicular means, of course, that they're going to form a right angle. So if BD is perpendicular to AC, I have right angles not only here, but also there. Okay, then they mention that BD bisects the angle. Again, it's the angle that's cut in half, although it is possible to cut another segment in half if they put a segment there. So just keep that in mind. But again, I'm bisecting an angle. So the angle ADC just got cut into two smaller but equal halves, both of which would be down here at D. So I've used my given information, but there's only 2 parts marked congruent so far. So I know by my shortcuts there has to be a third pair of parts. So if I look at my picture here, I see that the 2 of them share a side down the middle. That's something that they won't bother to tell you. You could go ahead and mark it congruent. and it gives me exactly what I needed to prove the triangle is congruent. If you look, it's two angles and the side in between joining those angles. So this is an ASA problem. And you have that on both sides here, two angles and the side in between. So I could say triangle ABD is congruent to triangle CBD. It's a mirror image, a reflection. Okay? Let's try one more. I just want to show one more. Okay, on this last one, suppose we know that AC bisects BD. And suppose we know that E is the midpoint of AC. We should be able to prove that triangle ADE is congruent to another triangle here and by a certain method. Okay, so if we take a look, here's an example now again where I'm doing some bisecting, but this time I'm going to bisect whatever follows the word bisect. So BD is the one that gets cut in half this time. AC is the one doing the cutting. So this one cut BD, there's BD, into two equal halves. So the two halves of BD are BE and DE. Over here is like another way of wording that same idea. I wanted to throw one of these at you as well. They mentioned the word midpoint. And a midpoint, as you know, is going to be directly in the middle. It also essentially does the same thing as a bisector. So if E is in the middle of AC, so if this E is right in the middle of AC, then AC is split into two equal halves as well. Now that's only two parts congruent, but if you keep a good eye out, you might notice we've got a pair of vertical angles. So if we mark the vertical angles congruent on this picture, I hope you can see now we can prove the triangle is congruent by SAS, the two sides and an angle in between. Okay, and the first triangle they call it ADE. So the other one, if you look, it's a rotation. So if this is ADE and you rotate it, then the other one over here would be called CBE. So that your A at the end of the double here would match up with a C at the end of the double there. The D's over here kind of at the end of the single. B's at the end of the single. And then the E's, of course, match up. Okay, so I think I've shown you enough of these that you should be able to do the worksheet that's attached titled Practice 30. Practice 30 worksheet. And again, make sure you're doing your marks on your drawing as well as filling in the blanks. I think there's a total of 8 problems of those.